This program looks at three different types of visual source material. First, we look at the work of a present-day craftsman in America, hand-making high-quality, personalized rifles and muskets for the contemporary market. From this, we get a unique and highly accurate insight into the skills which went into gun production in the late 18th century, and into the problems involved in such individualized hand production. Secondly, we move to what is now a museum, though formerly an early 19th century factory, where we're shown the machinery at work, which made possible the mass production of rifles. We look at examples of early 19th century guns, which demonstrate the significance of complete interchangeability of parts, which, note, was not achieved till the factory processes of the 1840s. Thirdly, we visit a mass production gun factory of today, though dating back to the mid-19th century. We see the way in which what was known as the American system of manufacturing broke down the processes once carried out entirely by the single craftsman into almost 500 different operations, division of labor with a vengeance, and how machines were invented, or more usually modified, to carry out these operations, and have become increasingly specialized and capable of providing large numbers of uniform parts which were easily assembled into identical weapons. Historically, note that the first pressure towards mass production came not from commercial demand, but from the military needs of the expanding American frontier and from the threat of external war. The actual processes, machinery, and artifacts which we are now going to see in the three different locations are described by the American historian Larry Wilson.
From the raw materials of steel, brass, and hard-grained maple wood, Alvin White, gunsmith of Cape Cod in Massachusetts, manufactures colonial-style muskets and rifles using the techniques of a gunsmith working in the 18th century. To make something as complex as a firearm by hand is highly skilled work. Parts must be precisely shaped and precisely fitted one to another. Alvin White carefully chisels out a central groove in the stock to receive the barrel. The fit has to be perfectly tight. If it isn't, the gun will be weakened and its accuracy diminished. Other parts will be fitted to the gun in relation to this crucial central alignment of stock and barrel. Alvin White works with simple hand tools or handmade machine tools like this rifling bench, which is of the sort used in the 18th century. The setting of the cutting points and the depth of the grooves to be cut inside the barrel are judged by eye. The machine transforms the hand power of the operator into a twisting, cutting action. There are no standard dimensions for the parts in a handcrafted gun. Each part is individually made and gauged by eye. Laborious hand filing is necessary to remove loose burrs left after forging, and above all, to fit parts one to another. There are 14 basic and essential parts in the complex firing mechanism of a musket, the lock. They are made to fit together through a lengthy process of fine adjustments. In the 18th century, this highly skilled work was often performed by specialized lock makers. Once fitted together, these parts will not fit into any other gun. In other words, they are not interchangeable. It is then virtually impossible to repair a handcrafted gun in the field. Replacement parts cannot be borrowed from other guns, but have to be made individually and fitted by a gunsmith.
He hasn't made into a screw yet, see? Okay. Perfect.
Carving the recess for the lock so that there is a tight fit between the stock and the metal parts is slow, painstaking work. As no two handmade parts are exactly alike, this process of fitting parts together has to be repeated anew for each individual gun. It took Alvin White over a month's work to make this flintlock Kentucky rifle. Handcrafted guns can be far superior in quality to any factory-made product, and it's this superiority that accounts for the survival of handcrafting through the era of industrialization. But making guns by hand is typically a small-scale business. Gunsmiths in the 18th century tended to work alone or as part of a local cottage industry. In the early 19th century, however, the expansion of the Army created a demand for weapons in America that the gunsmith, working in the traditional ways, could not meet. This was the Robbins and Lawrence Gun Factory, built in Windsor, Vermont in 1846. It was one of the most technologically advanced factories of its day. A British parliamentary commission visited the United States in 1854 to learn about American manufacturing methods and was particularly impressed by this firm. So much so that the British Enfield Armory was equipped largely with machines made by Robbins and Lawrence, and the first Enfield rifles were produced here in this factory. It now houses a fine collection of early machine tools. In the early 19th century, skilled labor was scarce in America and wage rates relatively high. This encouraged inventors and entrepreneurs to attempt to devise and build machinery capable of replacing the skilled craftsman. Once set, machines like this rifling machine can run without constant supervision. The machine is precise and tireless, and once installed, far cheaper and more efficient than hand labor. The depth and degree of the groove cut by the rifling cutter is controlled automatically by the system of cogs and ratchets. This type of stock-making machine virtually eliminated the need for skilled woodworkers in the gun industry. A cutting disc revolves rapidly and moves along the length of the stock, tracing the shape of the iron former or pattern. This copying principle removes the difficulties attached to producing such an irregular shape. It was quickly adopted in other industries to mass produce such things as wheel spokes, blocks for tackle, and shoe lasts. Supplementing this machine, others were developed to perform all the different tasks involved in making a gun stock, sawing the stock to the proper length and width, milling the bed for the breech of the barrel, and so on. These innovations revolutionized this aspect of the production of firearms and encouraged inventors to attempt to bring the machining of metal to the same degree of perfection. Powered generally by water, metalworking machines did away with many of the slow and laborious aspects of the production of gun parts. Before the invention of this barrel-turning lathe in 1820, barrels were ground by hand. The heavy rails at the bottom of this machine guide the movement of the cutting tool, ensuring accuracy and uniformity. The barrel spins and the superfluous metal is trimmed away by the cutting tool, which moves along the length of the barrel. Gauges were developed to measure minute but critical variations in the size of parts made by machine, and parts that were not of a standard size were rejected. In this uniformity and precision of manufacture lay the key to mass production. Milling machines were devised to provide an effective substitute for expensive hand labor in the operations of filing and chiseling. Each was set up to perform a particular operation in the production of one part. This machine has been cutting the profile of the lock plate here, and after that has been completed, holes drilled and buffing and so on, and the parts fitted on the back and the hammer on the front. The lock plate is ready to be inserted in the cutout on the stock at this point. A machine of this type is capable of producing hundreds of lock plates, and though they have to be checked against gauges, the main thing to worry about is that the cutting tool does not wear down and you lose the accuracy of the profile. The invention of the turret lathe in the mid-19th century was crucially important in manufacturing processes requiring the volume production of small, uniform components. This lathe produces screws but can easily be set up to turn other small metal parts. The turret, holding a cluster of tools on a vertical axis, makes it possible to perform a rapid sequence of operations on the piece to be machined without any time-wasting resetting or retooling. This machine produces standard and interchangeable parts that require little, if any, hand finishing. The development of such special-purpose machinery was a distinctive element of the American system of manufacture. As early as 1801, Eli Whitney claimed to have manufactured muskets on machinery with true parts interchangeability. But an examination of this musket of the model of 1812 contract proves otherwise. Removing the lock and examining the back shows individual numbers stamped so that the parts would be made to fit that lock and that lock only. A study of the lock from another musket of the same model shows that there are numbers on the back of that lock for the same purpose. And when attempting to fit this lock into the stock of the first gun, it simply will not fit. Going to a set of Model 1841 Mississippi rifles made here in the Robinson Lawrence factory shows that Robinson Lawrence, with the American system of manufacture, was able to achieve true parts interchangeability. Removing the lock from this rifle shows there are no parts numbers on the back. Removing the lock from the second musket shows that this too has no assembly numbers, nor were any needed. The lock from the first musket will fit the second. The lock from the second will fit the first. Simeon North, the manufacturer of this Model 1813 flintlock pistol, was required by the government contract to produce the parts with true interchangeability. But parts interchangeability and standardization are relative terms. Taking this piece of paper, it is possible to insert it between the lock and the stock on North's 1813 pistol. But with the 1850 Enfield musket produced at Robinson Lawrence, the piece of paper will not fit. The tolerances by government contract were much closer.
The development of specialized machine tools and the improvements in precision engineering of the mid-19th century opened the way to mass production. In America, this came first in the firearms industry because the gun was the one manufactured product required in large quantities. The possibility of large output levels justified the expense of developing the necessary machinery. In the late 1870s, several hundred employees worked here in what was the Winchester factory, New Haven, Connecticut, producing 10,000 rifles annually. Now it is the U.S. Repeating Arms Company. The machines in a modern gun factory are more refined and complex than their 19th century counterparts, but the principles of the machinery and the system of production remain recognizably the same. This modern computer-controlled version of a stock-making machine produces not just one stock at a time, but four. To cut the complicated shape of the lock recess into the stock, this machine has 16 different cutting stations. It is totally automatic. The increased specialization of machinery and the diminution of hand labor have been the continuing trends in production in the firearms industry. This small metal part is a component in the firing mechanism of a gun. It is processed through 4 special-purpose machines tended by the one operative. In 1841, an American observer of work in a gun factory wrote that, quote, "Machines for performing work that was formerly done by the skill of the eye and hand have been gradually introduced from time to time until at length the machines perform nearly all the work, leaving the workman nothing to do but to fix the article in a proper position, apply the necessary oil, and set the machine in motion. The machines are generally so constructed as to stop when the work is done without the aid of the overseer. In this way, a man can attend 2 or more machines. The skill of the armorer is but little needed. His occupation's gone." The mechanization of gun production in the mid-19th century entailed increased division of labor. Workers were skilled only in the making of one part or in one operation. While some factory workers were regarded as highly skilled machinists and as such amongst the best paid of American industrial workers, the majority were simply machine tenders, and this is still true today. The system of piecework and factory discipline replaced traditional artisan work practices. For the first time, women and children were employed in significant numbers in the firearms industry. With true parts interchangeability, parts can be selected at random and simply assembled, not fitted. To put a firearm together with only a screwdriver was a revolutionary departure from traditional craft practices. Much of the cost-reducing aspect of the new technology lay in this elimination of the need to actually fit parts. Characteristic of American machine-made firearms was a comparative lack of attention to finish and detail. Early machine-made guns were strictly utilitarian, functional models. Cheap, dependable, and easy to repair, they were ideal for the mass market. These are their modern equivalents. The lesson learned in developing the machinery to mass-produce firearms quickly spread to other industries. Handcrafting continues even today in a few specialized areas, such as the prestige, customized gun trade. But the American system of manufacture became the norm throughout American and then European industry during the second half of the 19th century.